All right, let's just get right to it. We're not going to talk about abstract theory today. We are going to engineer service level objectives, SLOs, that actually do something. You know, the kind that cut through the noise, get rid of those pointless false alarms, and give your team signals they can actually trust. So let's dive in. So, have you ever been there? It's 3 a.m., you're dead asleep, and your pager goes off. You jump out of bed, heart pounding, log in, only to find out it was some tiny little blip that already fixed itself. Yeah, we've all been there. And look, it's not just annoying, it's a sign of a much bigger systemic problem. And that whole 3 a.m. experience, it leads us straight to the heart of the issue we need to tackle. The way our industry thinks about on-call pagers is frankly pretty broken. What happens is you get this really dangerous thing called alert fatigue. When you bombard your engineers with a constant stream of low-impact noise, what do? They start to tune it out. It's just human nature, a defense mechanism, really. But the problem is, when a real emergency finally hits, it just gets lost in all that noise, and it might get ignored. Okay, so how do we actually fix this? Well, it takes a pretty fundamental shift in how we think. We have to stop chasing this impossible dream of 100% perfection and instead start being smart about managing imperfection. And that's where this key concept comes in, the error budget. I mean, this quote from Google's Ben Traynor-Sloss, one of the pioneers of site reliability engineering, just says it all. Trying to get to 100% reliability isn't just a waste of time. It actually makes things worse. You end up with brittle systems, development grinds to a halt, and your engineers get completely burned out. The goal isn't to stop every single failure. The goal is to manage its impact on your user. Okay, so this is super important. An error budget isn't a budget for making mistakes. Think of it as a pre-negotiated allowance for unreliability. It's the maximum amount of downtime or errors your service can experience over a certain period, let's say 30 days, before you've officially broken the promise you made to your users. Theory is great, right? But let's make this real. We're going to build an actionable SLO, step by step, and we'll focus on something that's critical to pretty much any online business, the checkout API. And look, this isn't some kind of dark art. It's a simple, repeatable, 4-step recipe. First, you pick a user journey that really matters. Then, you define how you're going to measure success. After that, you set a clear goal, and from that goal, you calculate your error budget. Simple as that. Let's walk through it. So, the very first building block you need is the service level indicator, or SLI. An SLI is just the raw data, a number you can actually track that tells you what your user is really feeling. You know, are there requests going through? Is the site fast enough? That's what an SLI tells you. So for our checkout API running on AWS, we could pick 2 really simple but super powerful SLIs right out of CloudWatch. First, success rate. What percentage of API calls are actually succeeding? And second, P95 latency. This tells us the speed for 95% of our users, which is way more useful than a simple average, because it ignores those crazy outliers and gives you a much better picture of the typical user experience. Okay, so we have our metrics. Now we need a goal, and that's our service level objective, or SLO. The SLO is where we take that SLI and we attach a target to it over a specific time window. This is our promise. This is what we're explicitly telling our users they can expect from us. For our checkout API success rate, let's say we set an SLO of 99.9%. That's 3 nines over a rolling 30-day window. This is our line in the sand. So what does that actually mean? Well, if our API gets, say, 10 million requests a month, a 99.9% SLO gives us an error budget of 10,000 acceptable failures. That's our budget to spend on whatever, new features, risky deployments, or just, things breaking unexpectedly. All right, so we've got our goal, but how does this fix the 3 a.m. pager problem? This is where it all clicks together. The magic is in alerting on the budget, not on every random little blip. Just look at the difference here. The old way, you get paged for every tiny spike. It's all noise, no signal, and it just leads to burnout. The new way, you only get paged when your error budget is being burned through at a rate that's just not sustainable. We're shifting from just reacting to noise to strategically responding to a signal that tells us our promise to our users is in real danger. So, picture this. It's the first week of the month. We've had a few small, totally expected failures. Maybe a little deployment glitch, a quick network hiccup. Our error budget is looking great. 95% left. No pages, no panic. The system is doing what it's supposed to do, absorbing small failures, and our engineers can actually focus on their work. But now look at this. A bad deployment goes out with a nasty bug. Errors are going through the roof. In just a couple of hours, we've burned through 40% of our entire monthly budget. This is when the pager goes off. And it's not a blip. It's a high signal warning that screams, hey, if this keeps up, we are going to break our promise for the month. That is an alert that people will wake up for and take seriously. And this is where it gets even more powerful. An error budget is way more than just a smarter way to alert. It becomes this common language for making better data-driven decisions about that constant push and pull between moving fast and staying stable. All of a sudden, everybody is on the same page. The product team can look at the budget and ask, hey, do we have enough wiggle room to risk launching this big new feature? SRE and DevOps have a clear signal for when to say, whoa, let's pause releases and focus on stability for a bit. And developers get almost instant feedback on how their code is actually affecting the real-world user experience. Just imagine this being said in a planning meeting. It's not a gut feeling, it's not fear, it's a simple, objective statement based on data that everyone already agreed on. The error budget just cuts through all the emotion and the politics and lets you have a rational conversation about whether you should ship more features or slow down and protect your customers. So I want to leave you with this question to think about. Take a really honest look at how you're doing alerting right now. Are those alerts actually protecting your service and your users? Or are they just creating a ton of noise and burning out the most important asset you have, your engineering team? Because switching to an error budget might just be the most important reliability decision you make all year.